So welcome back to Python scripting for GIS applications. This is a class at the University of Alaska Fairbanks, and it's spring semester 2013. From last time, your assignment was to write an Arcpy script that would add a double precision field to every polygon feature class in some workspace. And we'll name this double precision field hectares. And then once we have added that field, we'll use the calculator to calculate the area of hectares for every polygon feature class. So the first thing we'll do is set our workspace. So arcpy.env.workspace. So I double click on workspace equals, and then I'll just drag my geodatabase from my catalog window into my Python window. So that will set our workspace. So now, since we have our workspace set, we can create a list of all the polygon feature classes that are in that geodatabase. So we'll call this list something, I'll call it a list feature class equals, and then arcpy, and then the function dot list feature classes. Okay, so what we want is, in this case, I'll use a wildcard. So every feature class that starts with fire, and then the feature type, we'll use the keyword polygon. So then basically it's got to be a polygon feature type to be added to our list. So now we've got a list of all the feature classes in our workspace. So how many are there? So we could use the Python length function to determine how many polygon feature classes are in this list. So there's 68 different polygon feature classes, and if we want to know what they are, we could Control V to paste what's inside this list. So there are the 68 feature classes. They're basically for every year, all the fire polygons. So now what we want to do is for each of these feature classes, add a field called hectares, and it'll be a double precision field. So we can do that in a loop. So we'll call this variable input feature class in our list. So Control V to paste our list. Arcpy, and we want to add a field. So add field, and here's add field management. So I'll just double click on that. So the first thing it needs is the input table we're going to add a field for. So that would be this in feature class. And then the second thing would be, what are we going to name our new field? So I'll name it hectares. And then the third thing is, what is the field type? So we want double precision. So I'll just double click on double. And then right paren to end our add field. And then I just hit return and return to loop through every feature class in this list. So adding hectares to 1940, 42, 44, 48, and so on. Okay, so then for every polygon feature class in that workspace that started with the text fire, we now have a field, and the field is called hectares. So now what we want to do is calculate the area in hectares for every wildfire polygon. So if I press the up arrow key, we can recall our loop. And what we want to do is now, after we've added a field, we want to calculate that field. So that would be calculate field management. So I can press the tab key and then left paren. So the first thing it needs to know, what is the input table? So that will be our in feature class. And then the next thing is, what's the field we want to calculate? So that's the same field we just added. So we want to calculate for hectares. And then the expression. And the expression will be the same expression we used last week when we were calculating using the field calculator. So it's going to be shape.area would return the area property of the shape field, and then at hectares will return the area in hectares. And this is all enclosed in quotes. And the field is delineated in Python with a pound sign. So pound sign here for the start of the field, and then pound sign here at the end. And then comma, and then the last thing is expression type. So here it's a Python expression. So that will calculate for every polygon in every feature class in this list the area in hectares. So it's looping through and it's calculating for every feature class in that list the area in hectares for every polygon. So for example, here we have for the fires in 1940, our new field called hectares, and then we have the correct value in hectares for each fire polygon for that feature class. Okay, in this session, what I want to do is teach you how you can use Arcpy scripting with geoprocessing tools that may have more than one field or parameter. So for example, here's a summary statistics tool. And what we want to do is write an Arcpy script that will create this table. So for every year, so that's our case field burn year, go to the hectares field and add up all the hectares burned for that year. So to do that, there's actually two ways you can do it. One is you can create a list of field and statistics type, or you can create what's called a value table. So I'll teach you both of those methods. Okay, so we're going to work with a feature class that has all the fires in Alaska from 1940 to 2012. And then what we want to do is use the summary statistics tool. So what we want to do is first create a list, and the list will be items that we want in terms of statistics. So the way the list works is it's actually a list inside a list. So this will be our first statistics field and statistics. So we want hectares, and the statistics type will be sum. And then the next list will be hectares is the field, and then the statistics type is the mean. And then we want to do this for each year. So that will be our case field. So we could just basically make our case field as a string. So then we can use the summary statistics tool. So that's arcpy.statistics. So double click on statistics analysis. And that requires our input table. So our input table, we could either select this, which is in my table of contents, or this variable. So I'll just use the variable input feature class. And then an output table. So I'll just call this test1 out. You could call it whatever you want. And then statistics fields. So that's going to be our list, which is actually a nested list. So it's a list inside a list. So here's my first list inside that list, and here's my second list inside this list. So list stats field. And then my case field. So my case field in this example will just be burn year. And then that should create a table for every year, every burn year, give me the total hectares burned and the average of all those polygons for that year. Okay, so then we could look at that output table in ArcMap. So the output from the summary statistics tool that we executed in the Python window gives us this table. So for every year, that was our case field, we have the total hectares burned. So that was the one item in our list. And then the mean hectares for each year. So that would be the average of all the polygons. Okay, the other way we could do this is using something called a value table. So a V table or a value table is basically a temporary table It's just used virtually, and it'll disappear after you exit ArcMap. So basically what you do is first define how many rows will be in this table. So in this case, we'll have 2 rows in our table. And then we populate this virtual table. So our first row, we're going to populate with the field name and then the statistics type. So our first row will be the 0 row, and it will be populated with, we want it for the field hectares, the statistics type sum. And then we would do the same thing for our second row, which will be the mean for hectares. So now we've got this virtual table, and it's got 2 rows, and it actually has 2 columns. So the first column is hectares, and the second column is sum and mean. So now we can use this virtual table in our statistics command. So arcpy.statistics, and then our input feature class. And then our output table, I'll call this test2 out. And then the statistics. So here is where we would tell it their table. And then our case field is burn year. So that should give us the identical table. So if we look at test out, so we do get identical results. So this was the first one where we used a list, which called for our hectares field give us the sum, and our hectares field give us the mean. And our second one was where we used that virtual table, where inside our table, the first row was hectares sum, and the second row was hectares mean. Okay, if you go to the NRM 638 website, I have the homework assignment for you for this week. And the assignment is basically to write some Arcpy geoprocessing scripts in ArcMap. And you'll have 5 problems that are candidates to solve. And your assignment is to solve 3 of these 5 problems. So the first problem will be salmon counts by stream name. So ultimately what you'll do is create this table of by stream name sorted, the number of salmon by species. And then the next assignment would be percent permafrost within watershed basins. So you'll ultimately produce a table that will look like this. So sorted by percent permafrost, each watershed basin. And then the third problem is percent area by vegetation type. So ultimately your script will produce a sorted percent of the area by vegetation type. And then the fourth problem is a wildfire simulation problem. So basically what you're going to do is randomly select a black spruce polygon and then burn all the black spruce polygons that are connected to this randomly selected black spruce polygon. And then the fifth problem is comparing modeled versus actual snow extent. So ultimately, your script will produce a table that will look like this. So for week 1, this was the true extent of snow on the ground, and this was a model prediction, and this was the area of overlap between the actual extent of snow on the ground and the model's predicted snow extent on the ground. And the snow melts, and as we get to week 5, we have less snow on the ground, and our model predicts about 45 hectares on the ground. And those 45 hectares are all inside the actual snow on the ground in week 5, which is 119. So those are the 5 choices you have for this week. And what you have to do is write 3 Arcpy scripts that will solve those problems. And those are at the NRM 638 website.